So example 7 should be done. It doesn't really matter that it's done already. We're redoing it anyways. So go to your y equals and clear that out. Because before you start any question, you should always clear out your y equals. Why do I say that? Because there will be someone or some people in this class who will not clear out their y equals and will answer every single question on the test with one y equals from the very first one they found. And how do you think your test is going to go? Badly. Okay? So we're going to clear out our y equals and then we clear out our list. We don't delete them, we clear them. So put the data back in. I know you may have done this already a few times, don't really care. Put the data back in again. And we're calculating a cubic regression. What happens if your lists aren't the same length? It'll get mad at you. Okay, so it says in an experiment, the volume V of 1 kilogram of water is measured as its temperature T is increased. So as we increase the temperature, they're measuring the volume. Okay? So stat, calc, cubic. And we're going to put that into our, this one, if we look at our R squared value, because we didn't have the R squared value before, 0.99999, that's almost 1, right? So that's pretty darn close, pretty good. If you get one that's like 0.92, it's kind of crappy, and you'd be like, oh, I'm going to try the other one. You can't. If it says cubic regression, you don't get a choice. You have to do what they tell you. Bless you. So get it into your y equals and change your window to suit the data. We're doing linear, or cubic. It says cubic right below it. Okay. All right. So, our equation we should have, and I know it says nearest hundredth, but in some places that's not that helpful. But anyways, it's negative 6.89 times e to the, actually it would be negative 1, 2, 3, 6, 8, 8, 8, x cubed plus 0.008547 x squared minus 0.0647301 x plus 9.86976. I just randomly put when I felt like it. So that's all that was. What we need to remember is our y equals, we can't put in rounded decimals. We have to transfer it by using the bar button, right? Okay, so they want the volume. Determine the volume of the water when the temperature is 40 degrees. Did they give me X or Y? Temperature 40 degrees. They gave me X because temperature is X, right? So X equals 40. So how do we do that? We go second trace value, 40, enter, and I get y equals 1006.55 centimeters cubed. So would we have to write a sentence on the test? Yes, it would say the volume of the water at a temperature of 40 degrees Celsius is 1006.55 centimeters cubed, 0.55 centimeters cubed. Yeah? Sentences every single time. Here it says determine the temperature. So now we're trying to find the temperature when the volume is this. Volume is y. So we have y equals 1001.46 centimeters cubed. Where does that go when I know y? Into my y2. 1001.46. Now, sometimes you can't see it intersecting. What I always do is as long as it fits in there, the window, I go second trace 5, enter, 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 and I hope it calculates it, which it does. These windows, these lines are really, really close together. So x equals 20.09 degrees Celsius. I would have to give you a rounding rule. And then it says the temperature is 20.09 degrees Celsius when the volume is 1001.46. And we're going to skip that D for now. Okay. Here we have a spherical balloon is being inflated. We're starting a new question. What's the very first thing we do? Go to our y equals and clear it out. Then we go to our lists and clear those out. But always clear your y equals first. So here we have a spherical balloon is being inflated, the volume V in centimeters. Cubic centimeters is related to the time T in seconds. Time is X, volume is Y. Type it in and get a cubic regression. The R squared for the cubic here is 1, so 100% of the data fits it. Go to your y equals and move it into your y equals. And change your window. Okay. So I need the cubic regression for this one. It's y equals 4.19 x cubed plus 25.13 x squared plus 50.27 x plus 33.5. Now it wants us to determine the volume at 10.5 seconds. Did they give me x or y?
They gave you x.
They gave you x because you look at the units on your table, right? So x equals 10.5, and like I told you, if you can't find it when you put it in, it's because your window isn't big enough, usually in the x value. So second trace value, 10.5, and I get an error because my x max is 10. Second trace value. Make sure you're using your own calculator because you won't find the errors until you do that. So V equals 8,181.47 centimeters cubed. And we'd have to write a sentence. Then this one says, determine the time at which the volume of the balloon was 1,000. So once again, they gave us Y, 2. And now we want to calculate where they intersect. And I get x equals t, I guess, equals 4.20 seconds. And then I would write a sentence. The time at which the volume of the balloon was 1,000 centimeters cubed is 4.2. It says nearest tenth. Take that 0 off because that is wrong. 4.2 seconds. All right. Then we're going to example 9. What's the first thing we do? Go to our y equals, clear it out. Then go to our lists, clear them out. You guys don't have a list? A dolphin jumped out of the water in a tank and then dove back in. The dolphin's height in meters above the water is given by this table. Time, height. Use a quadratic regression, so we don't get a choice. It's quadratic. Determine the maximum height of the dolphin during the jump. Make sure you make your minimum for y negative because this dolphin is jumping into the water. Water level is 0, right? So we can have negatives. But I guess no, good old quadratic. If you put the equation into your actual y equals, it'll give you 1, which I did not. Okay. Poof, there it is. Okay, we want the maximum height of the dolphin. So second trace, maximum. Is height x or y? On here, is height x or y? So I'm going to get a maximum coordinate. It is at 1.54 comma 1.41. And then I put units on it to help myself out. Did you not get that? Quadratic. Yes, no, maybe so? You got the same thing as this or not the same thing? Did you give me the X or the Y? You got 1.5, what did you get for your coordinate?
I got 1.50.
For this? The Y or this? You got what? You got this? Check your data, peeps. Check your data. Make sure it's the same. 0.51, 1.5, 2.5, 3.5. It looks like it rounds it, but it doesn't. No. Like if you go and click on the data, it'll show you that it's still there, even if it looks like it. Okay. Yeah. So this one is S for seconds. This one is M for height. Guys. So when I go and find my maximum, I will always put the units on it so I don't pick the wrong number, because they'll have both number options in your multiple choice. One of them is wrong. Okay? This one asks us for the maximum height of the dolphin during the jump. Which one of those is height? 1.41 meters. If you put the units on your maximum or minimum coordinate, you won't screw up. If you don't put the units, I get a lot of people writing 1.54 meters. No. At 1.54 seconds, he reaches the maximum height. Sometimes they ask for the time to reach maximum height. Okay? So, the maximum height of the dolphin during the jump was 1.41. Okay. The last thing we're going to talk about is polynomials, and then we actually move on to a totally different unit. But the last thing we're going to talk about with polynomials is, what if they give me the equation? So actually people are like, oh, if they give me the equation, it's easier. Often it's not for you guys because it's not as obvious what to make the windows. Like when you have a table of data, it's a lot easier to figure out your windows, right? You go below the lowest, you go above the highest. Nice to make windows. When they give you a full equation, it's different. So these are all the things that can be asked. Can everyone pay attention and make sure you highlight on things you don't know? So for a polynomial equation given, if it asks for the moment the item is released, so say the moment you release a football, or the moment you hit a golf ball, or the moment they drop a ball off the edge of a I don't know, skyscraper, which I wouldn't suggest. Because momentum, talk about physics, it wouldn't be good. So, ask for the moment the item is released. They're asking for the y-intercept every single time. They're asking when x equals 0 or time equals 0, right? If they're asking for moment of release, that's when I'm holding the ball. The moment I release it, that's time equals 0, right? They want to know what it is before I let go. Okay? If they ask for the height at time 0, they're asking for the y-intercept. So these are the exact same thing, correct? Just asked a different way. Still time 0. If they ask for the maximum or minimum height, they're asking for the y of the maximum or minimum. If they ask for the time to reach max or minimum height, they're asking for the x of the max or minimum. You need to know if they're asking for the x or the y. If they ask for when the object hits the ground, they're asking you for the x-intercept value, the positive x-intercept value, right? So when it hits the ground, if it's like this, they're asking for this. So they're asking for when y equals 0. If they give you a specific y and ask you to find the specific x, you put it into y2 and find out where they cross, correct? If they give you a specific x and ask for a specific y, then second trace value x equals, you put the value in. And this is the key thing. Remember, domain and range are restricted in word problems as you cannot have negative time or negative length. Always make sure you only list values that make sense in the question. So if you get like time equals negative 4.1 seconds, no, you're not going back in time. So that one wouldn't count. So here's an example. The growth of a tree can be modeled by this function. So now they gave me the equation. They didn't make me find it, correct? What type of equation is this? Linear. So where h represents the height in meters and t represents time in years. So we're going to answer alternate questions on this. So I want you guys to type this one into your calculator and see if you can answer these questions. Go. All right, please. So if we want to know this, h represents the height in meters. H is here. Do you see that? So what is h then? Y or x? Y, because it's y equals, correct? And then t is in the spot of what? X. Okay. So here it says, to the nearest tenth of a year, approximately how long will it take the tree to grow to 32 meters? So we could actually solve this one algebraically if we wanted to, because that's the height. We could add 0.45 to both sides. And we'd have 32.45 equals 2.3t divided by 2.3, and t equals something. T is not the height of the tree. T is time in years.
So C is a distractor.
No, you picked that one? Don't know why, but if you put it in the wrong one.
C is a distractor.
Yeah, they're all distractors in some way. Yeah. Okay, so I get 14.1. Okay. Then it wants, what is the original height of the tree? What's that a fancy way of saying? Time equals 0 years. Right? So we could type it into our calculator, or we could go h of 0, because t would be 0, equals 2.3 times 0 minus 0.45, because it's the y-intercept. Now, some people panic. They panic. They're like, how in the heck, Lepp, could this ever happen that a tree might be negative 0.5 meters? And then I would say, it's a seed. Planted in the ground. If you don't understand it, supposedly, if you've watched the Lorax, this makes sense that a seed would be in the ground. Just going to throw that out there. Okay. Okay, determine the height of the tree in 23 years. So t equals 23, which is just our x, correct? Now remember, if your x max is not bigger than 23, can it find this? No, second trace 1, 23. Could we have just typed it in for the t? Yeah, we could have just went h of 23 equals 2.3 times 23 minus 0.45. You could have just done it algebraically. And you would get 52.45 meters. Tall tree. Okay? Then we're going to flip over. Okay, this one, a science class. We're going to read. Crazy. I know I keep saying this. People still continue to not read. A science class is investigation trajectories. Maybe I should learn how to type. Is investigating trajectories by launching balls with a catapult. The pathway of one particular ball can be modeled by this quadratic function. It is concave down, correct? It ends down on both sides, which is good because it is a negative leading coefficient. What is the y-intercept of this case? 0.5. So what would that possibly be? The height of the catapult? The height of the catapult? It's times 0, correct? The height of the ball at the moment of release would be 0.5, so probably the height of the catapult. Where h is the height of the ball above the ground, so this is y. And t is the time elapsed. You see there's a few t's? That's my x in seconds since launch. So if we want the range of the height of the ball hitting the ground, it's going to start at 0 and it's going to go to where? I don't know. We calculate. It's max height, correct? And then our time is going to go from 0 till the ball hits the ground, which we have to find. Okay? You try it out. Something that looks like this. If you have a teeny tiny screen like me. Or if you adjust it, it should be like the whole thing, right? A massive window here. Okay, so what we want, everyone paying attention? This is the ball being catapulted. This is the only part we care about. So times 0, and then we have to find out when it crosses the x-axis, which is number 2, left bound, right bound. There we go, up here. Boom, boom. So this one, bless you, is at 1 point. Did I type it in wrong? It is 4.9 x squared plus 0.5. Crystal, grab a mitt. Get in the game. Typed it in wrong. Okay. Second trace. Anyways, 1.5, right? So it's between 0 and 1.5, which is either this one or this one. Bye-bye. Okay? Then, yes, I started at a certain height. The height of the catapult is 0.5, but it still does come down to ground level, correct? So 0 to whatever the heck this is. So second trace, maximum. Then I go left bound. 7 years from now when it gets there. Right bound. And I get 3. So it's between 0 and 3 for H. So it's not that one. So it's C. Okay. This one wants the ball the moment it was released. So that's when time equals 0. So I go H equals negative 4.90 squared plus 7 times 0 plus 0.5. So H just equals 0.5 meters. And we would need a sentence. Determine the maximum height of the ball. We calculated that. It was 3.0 meters. Determine the time the ball reached the maximum height. That's the x. So it's 0.71 seconds. Determine the time the ball hit the ground. 1.5 seconds. We found that. Determine the height of the ball at 0.5 seconds. So we can either plug 0.5 into our formula, or we can go x equals t equals 0.5. So we go second trace value 0.5, and I get 2.775 meters. And then determine the second time. So when I go to my y equals and I put in 1.2, there's 2 times it crosses, correct? Sometimes it asks for both times. This one asks for the second. So I need to get my intersection over close to the first or the second intersection, and I get 1.32 seconds. Determine the time the ball was above the ground at 0.75 meters. So once again, that is y2. There's just only one time that happens. Second trace 5.